Welcome to Brain Vision.
If the terminal voltage is to be 3 volt, then the voltage across R1 will be 9 volt. So V1 will be 9 volts. Now this can be used to find the current, which will then be used to find the value of R. So let me just write the equation so it will be clear what I mean. So this is Ohm's law for the voltage across R1, and I is the current flowing through R1. So I will be equal to V1 over R1. Similarly, by Ohm's law, we can write V2 to be equal to I R2, where V2 is the resistance across R2, and since they have the same current, therefore we are using the same notation I. Now let's plug this expression over I over here. So we have V2 equal to V1 over R1 times R2. Now from this expression, we can find R2. So R2 will be equal to V2 R1 over V1. And let's plug the values now. So V2 is 14 point, V2 is 3 volt, R1 is 14.5 ohms, and V1 is 9 volts. And this gives R2 to be equal to 4.833 ohms. And approximately this is 4.8 ohms. So V2 here is basically the value of the terminal voltage that we used. So this expression is for the terminal voltage, and this is for voltage across R1. Now for part B, if the load has a resistance of 7 ohm, then the parallel combination of R2 and the load must be used to analyze the circuit. So R2 plus load. This is the parallel combination of R2 and the load. So instead of doing that, let's say RP. So RP is the equivalent resistance of the parallel combination of R2 and the load resistance. So RP will be equal to R2 times RL over R2 plus RL. Now plugging the value of R2 that we calculated in part A and the given value of load resistance, we find RP to be equal to 2.859 ohms. Therefore, the equivalent resistance, let me just write that in the next page. So the equivalent resistance will be RP plus R1. Now let's plug the values of R1, which is 14.5 ohms, and RP over here to get the equivalent resistance, and that turns out to be equal to 17.359 ohms. And by Ohm's law, we can again write the voltage to be equal to current times the equivalent resistance. So the current will be equal to voltage over the equivalent resistance. And voltage is sum of V1 and V2. So that is equal to 12 volt over the equivalent resistance, which is 17.359 ohms. So solving that, we get current to be 0.6913 amperes. Now since the path RP and R1. So since these two resistors RP and R1 are connected in series, therefore this is the same current that flows through the terminal voltage. Sorry, this is the same current that flows through this RP, this parallel combination of R2 and the load. So VT, which is voltage across the terminal voltage, which now has a load resistance. So this will be equal to current that flows through this times RP, which is the equivalent resistance of the parallel combination. So let's solve for that in order to find the terminal voltage, and that comes out to be equal to 1.976 volts, or approximately we can say that to be equal to 2 volts. And so now we have VT 2 volts, whereas before, where when there was no resistance on the load, we had the terminal voltage to be 3 volts. Therefore, we can see that the presence of the load has affected the terminal voltage significantly.